Alright, our fourth video in the unit. Hopefully you were able to access this through Schoology, and that'll allow you to have that forum there on Schoology where if you're having any troubles with either the concepts or with the videos, you can post a question to one another on Schoology. You can have some conversations in there that'll hopefully be math-based and help you out a little bit. So, moving on to our topic of the day, we're going to discuss solving inequalities today. And most of you are very familiar with our inequalities, the greater than or equal to, less than or equal to. You've used them before. The big difference being with the equal to idea is inclusivity, where you are including the value. So if you say x is greater than or equal to 3, you're saying that x could be larger than 3 and it could be 3. It includes the value 3. When if you just say x is greater than 3, that means that we're talking about numbers that are only larger than 3. 3 is not included in the value. Alright, when we solve inequalities, we're going to be looking at inequalities just like equations. You're going to solve them in the exact same format you always have, where you're going to do inverse operations. If you see x plus 2, you're going to minus 2. If you see negative 5x, you're going to divide by negative 5. Exactly the same steps we use in solving equations. There's just one special rule we have to be careful with when solving inequalities, and that's whenever you're multiplying or dividing in order to solve. If you multiply or divide both sides by a negative value, now again, it only applies if you're multiplying or dividing by a negative value, your inequality sign will flip. And the reason why that happens is when you divide by a negative number, you're changing every sign in the problem. You're changing every positive to a negative, every negative to a positive. That also affects the inequality sign. So that inequality sign will change as well. Less than will become greater than. We're also going to be graphing all of our solutions to inequalities. And when we talk about graphing solutions to inequalities, it's a little bit different than your typical graph. We're only talking about a number line. And on that number line, we're going to graph all the solutions to an inequality. So when you do that, you have to make two separate decisions. One of them is going to be whether you have an open circle or a closed circle, and the other will be the direction your arrow points, left or right. And so when we look at our example of x is greater than 2, our first decision we need to make is whether or not it's an open circle or a closed circle. And how we decide that is that idea of inclusivity again. In this case, we are not including 2 because it's x is greater than 2, not greater than or equal to. It is greater than. So we are not including 2. That means we're going to have an open circle. An open circle is not included. A closed circle is including that value. And then the second decision comes, does our arrow go left or right? Well, we're graphing the solutions to this equation, and so our solution is x is greater than 2. So we don't know what x is, but we know it's a number larger than 2. And so therefore we put the open circle at 2 and the arrow goes to the right, as that's where the values are that are larger than 2. So we're going to run through one example just to make sure we understand the concept and what we're doing. When we look at negative 3x minus 7 is greater than or equal to 5, this will bring up everything we'll need to look at in this section in one example. First thing we solve in our standard form, we add 7 to both sides. That gives us our negative 3x is greater than or equal to 12. Then we divide both sides by negative 3, and now we're in our special case. We're in our special situation where we divided both sides by a negative. That leaves us with x and negative 4. But because we divided by a negative, we have to make sure we flip that sign from greater than or equal to less than or equal to. And then it's time to sketch that on a graph. And so I have to make my two decisions. My dot is going to go at negative 4. Is it going to be open or closed? In this case, it's going to be closed because we have an equal to value. We're including the point negative 4. So we color in our circle, make it a closed circle. And we're graphing the solutions for x is less than or equal to negative 4. So therefore x could be any number negative 4 or smaller. So our arrow goes to the left. Now the little more difficult thing we're going to come across at the end of our unit here is compound inequalities. Anytime you hear the word compound, that means you have more than one thing being involved. And in our compound inequalities, we're going to have two different situations. We're going to have the difference between and situations and or situations. And when you think about that, and means you need multiple things both occurring. Or means one or the other can occur. You have to graph them both. You have to consider both situations. So when we look at our and situation, oftentimes an and situation will be presented like this, where you have 12 is less than 3x is less than or equal to 18. And so we've taken two separate inequalities and written them as one mathematical statement. And so when we solve that, we do have to consider it like it's two separate inequalities. And we solve the one on the left, where you get 12 is less than 3x, we solve that by dividing by 3. And then we look at 3x is less than or equal to 18, our inequality on the right, and we solve that by dividing both sides by 3. So for many of you, you're just going to use this format and just treat it all as one problem and say, to get x by itself, I need to divide by 3. I just now have 3 sides to my inequality that I have to divide by 3. So that leaves us with 4 is less than x, which is less than or equal to 6. When you look at the picture, what that says is when you have x is bigger than 4 but smaller than or equal to 6, that would be the English word of in between, where we're looking at x is in between 4 and 6, including 6. So when we go to graph that, we're saying x has got to be larger than 4, so we have an open circle at 4, and x has to be smaller than or equal to 6, so we do a closed circle at 6, and we connect the dots, graphing the area in between, because that's what an and situation is usually referring to, is the concept of in between. So an or situation is a little bit different. We have two inequalities. 3x minus 2 is less than 13, or negative 4x is less than or equal to 32. Now this is an or situation, so one works or the other works. We have to solve them both independently. So we go through and treat them as completely individual problems. On the left, we add 2 to both sides, giving us 3x is less than 15, and then we divide both sides by 3, giving us x is less than 5. On the right side, we have negative 4x is less than or equal to 32. We divide by negative 4, giving us x and 8, and again, we're in a situation where we have to flip our signs. We get x is greater than or equal to 8. For the or situation, when we go to make our graph, we have the x is less than 5 or x is greater than or equal to 8. Because we don't have a limitation on an or situation, we have to graph them both. We graph the open circle at 5 with an arrow to the left and the closed circle at 8 with the arrow to the right. If you have any questions about this, please either post them on the Schoology website or come into class with them tomorrow, and we will see you tomorrow.